We will continue our discussion of rational numbers by looking at what happens when you take a rational number, or more specifically, in this case, a whole number, a smaller group of the rational numbers, and multiply that number by itself. The result is going to be something that we call a perfect square. So when we look at something like 1 to the second power, we should recognize that as an example of a power. It's taking a base number of 1 and we're being asked to multiply it by itself. So 1, and we read this as 1 squared, or 2 squared, or 3 squared, and so on and so forth. The purpose of a power is to allow us to repeatedly multiply, and we can see that by way of writing the power as a product. The product is going to be nothing more than writing it as repeated multiplication, 1 times 1. Because that's what 1 squared tells us to do. 2 squared tells us to take 2 and multiply it by itself. 3 squared asks us to multiply 3 by itself, so 3 times 3. 4 squared, multiply it by itself is 4 times 4. And I think you're beginning to get the picture here. So 5 squared is 5 times 5. 6 squared is 6 times 6. These are all examples of products. Now, the result of those products, by the time we're all done, when we raise a number to the second power, meaning we multiply it by itself, is that we get a perfect square. So the resulting perfect square here is a result of 1 times 1. So let's go through this. The power of 1 squared is written as the product of 1 times 1 and gives us the perfect square of 1. The power of 2 squared gives us the product of 2 times 2 and gives us the perfect square of 4. One more time, the power of 3 squared gives us the product of 3 times itself, 3 times 3, and that gives us 9. So we'll just continue this. We'll see that 4 squared, which is 4 times 4, is 16. 5 squared, which is 5 times 5, is 25. 6 squared, which is 6 times 6, is 36. So it's important that we understand the terminology. The power is the number raised to an exponent. The product is the repeated multiplication representation of that power, and the perfect square is the result of actually doing that repeated multiplication. So I'm going to pause the video and I'm going to quickly ask you to write the result, or write both the product of each of these powers, 7 squared through 12 squared, and the resulting perfect square. So I'll pause the video and let you get caught up. So if you completed your list correctly, these are your resulting products and perfect squares of 7 squared all the way through 12 squared. So we will move on. What we want to do now is think about what the undoing of a perfect square is, or what the undoing of squaring something is. I'll say that informally as unsquaring, but the word we want to focus on is taking the square root. So that's going to basically have us working backwards. If I already know the perfect square, a number is a perfect square of 144, then when I take the square root of it, I know that the result is 12. And essentially, taking the square root is asking you to find a number that multiplies it by itself to give you the resulting perfect square. So mathematically, the way we show a square root is with this symbol right here. It kind of looks like a long division house. And we read that as the square root of 144. So we're essentially saying, hey, when we are looking for the square root of a number, we're looking to find a number times itself, otherwise known as raised to the second power, raised to the power of 2. That equals the given perfect square. Now that sounds complicated, but it's really just unsquaring. So in this case, I'm saying, hey, what number times itself gives me this resulting perfect square? And we already know from looking at the table, the square root of 144 equals 12. Likewise, the square root of, say, 100, find the number multiplied by itself that equals 100, the square root of 100 would equal 10. So it's that simple. So given the list that you see up above, all the perfect squares, and this is important, listed above will result in whole numbers. All the numbers, all the perfect squares listed above will result in whole numbers when we take their square root. And being that they are whole numbers, they will all be considered as rational numbers. Now that's important because we're going to continue our discussion soon about what irrational numbers are. So we need to understand that perfect squares are numbers that when we take their square root are whole numbers, and by definition they are rational numbers. So that is what the scope of this discussion is today, for you to understand clearly what the square root of a number is. It's unsquaring. And as long as we're looking at numbers that are perfect squares, we are going to consider the result as being whole numbers and therefore rational numbers. And that will lay the foundation for us to move on to talking about irrational numbers.